Okay, it's on. Hey guys, first video for our remote learning experience together. Okay, so I'm trying to make this where we're taking a couple of concepts, a couple of objectives, squeezing it down into a relatively short video. Okay, now if you have your notes with you, you can feel free to write in those, but if you don't, here's what you can do. You go into your chemistry folder. In this case, I'm looking at second period. There is a Chapter 9 Resources 2020. You can click on that, and then right there it says Structural, Molecular, and Empirical Formulas Notes. You can click on that. It is actually a Word document. What I did, I took my PowerPoints and I put those in Word. So you can actually write in that. You can type on that in class, or wherever you're viewing this. Okay, let's get back to the main point here. So in chemistry, we deal with different kinds of formulas. Okay, now the first kind, we have structural and molecular formulas. Structural formulas tell us the number and types of atoms that are involved. How many oxygen atoms, how many carbon atoms, and so forth. But the difference is, it's how those atoms are put together. You might remember, a few chapters ago, we dealt with something called the Lewis dot structures, Lewis dot diagrams, or Lewis diagrams. And really, the idea was showing how did these atoms connect with each other in terms of the valence electrons. You might remember that. So here is an example of one right here. This is a structural formula. Okay, so we have an idea what the structure looks like. We've got a hexagon here, we have a pentagon here, we have a few double bonds there, but we have pretty much a lot of single bonds in there. That's a structural formula. Okay, now we can look at an expanded structural formula here, CH4. This is what it looks like. Okay, pretty straightforward. That's methane. Now we can add onto it, add another carbon, and we can make that carbon chain a little longer. And that's CH3, that's ethane. And then we can add another one, and then that would make it propane. So these are structural formulas. This is what they call condensed. I am not worried about that. I'm only interested that this is the structural formula. You understand that idea. It shows how it's put together. But we also have to look at the molecular formula, okay? Because it does one thing. It's more packed in, it's more condensed, it's shorter, okay? What do I care? If I really don't care how the atoms are put together, the molecular formula is going to work for me because it still tells me how many of each kind of element do I have. It doesn't tell me where it goes or how it goes. It just tells me, here are the parts, like the car. Here are your wheels, here's your tires, here's your transmission, here's your brake system, here's your drive shaft, here's your gear lever, here's your electronic fuel injection system, and so forth. Okay? So let's do some examples here. So name a compound, starch. The molecular formula is C6H10O5. Okay? All right. Glucose, C12H22O11. Now you kind of notice it's gotten a little bit bigger. These are molecular formulas, but they don't tell you how it's put together. Then there's acetic acid, which is basically vinegar, C2H3O2. Okay, and then there's ethyl alcohol, otherwise known as ethanol, okay, which they can add into gasoline, C2H6O. So all of these are molecular formulas. They all tell me there's carbon, there's hydrogen, there's oxygen, and how many of each kind. Because remember, the numbers tell you. It gives you the identity of what that material is that you're working with. Okay, let's take another look. So if we look at structural versus molecular, why would we care? I mean, if structural tells us how things are put together, but all we really need are just the pieces and the number, why would structural be so important? Well, let's take an example here. We got two molecular formulas here, C4H10. They're both the same, but here's the difference. There you got 4 carbons arranged in a ridge, a backbone, if you will. Hydrogens all around it. That's called butane. You'll find those in cigarette lighters. Okay? Now, what happens if you take one of those carbons and stick it in the center carbon like this? Now, you look at this structure, they're not the same. You're right, but they're made of the exact same pieces. Okay? This is called isobutane. Iso meaning, hey, one of these has been isolated from the others. Okay? Now, that's the thing about the wonders, where people can make the argument, we're made up of the same materials as the stars of the nighttime sky. Right. But my point is, it's how those atoms are put together. Look at the difference between them. Same pieces arranged differently, and guess what? They're going to act differently too. And that's the wonder about creation. That's the wonder about how God put things together. How He put human beings together. Individually, unique, wonderfully made. I'm echoing Dr. Cruz at this point. But guys, that's it. That's the difference between structural versus molecular. Molecular, everybody's been quoting molecular for years. CO2, H2O. But structural, it tells us how these things are put together. And you can have the same pieces but arranged completely differently. Okay, hey, let's round up. Let's wind this one down with empirical. Now, the empirical formula, and I showed you guys the wrong version of the thing. Not a problem because I got the real one right here. Okay, so the empirical formula shows the number and kinds of atoms in the simplest ratio. This is a little bit different, okay? And that's all the empirical formula is. You're looking here, CH2O. That's formaldehyde, which they use to preserve specimens. They will preserve human bodies for a funeral service, things like that. H2O, water. You can't get any smaller than that. There is no such thing as H1O1 half. It doesn't work that way. You don't have a half an oxygen atom. CH4, methane, CH3, ethane. Those are empirical formulas. So if I've got something that's like C2H4O2, is this an empirical formula? Yes or no? 50-50. And the answer would be no, it's not. Well, how come? Because I can divide all of these by 2. And I get CH2O. That's it. This is an empirical formula. This is not an empirical formula. Okay? That's the difference with it. Hey, I hope this little talk helped you and understand a little bit more as we ended up checking out the following things. We looked at the empirical formula. Smallest whole number ratios. You can't divide it any further. Did it quick. We looked at the difference with structural versus molecular formula. We looked at the idea that structural will tell us the number of pieces we have, the kinds of pieces we have, meaning atoms, and how they're put together. Whereas a molecular formula just tells us how many pieces we have and what kind of each piece do we have. So I can have C4H10, that's nice, but it doesn't tell me how it's put together. The structural formula will tell me how it's put together, and even then, it has to be specific. Just like you, and your family, and your friends, and your teacher, we're all uniquely made. We're all unique. All right, guys. So, I hope this finds you well. You guys take it easy and have a good one. Hasta.